And between APAN59 and APAN60, we had there is some echo. We had established we had established a connection with Loginet.
My PC's time.
Yeah, my PC.
Yeah.
So repeat the audio.
Oh, sorry.
Yeah, maybe it's work.
Yeah.
Yeah, okay.
Thank you. Yeah.
Yes.
Between APAN59 and APAN60, we have established cross connect between Hong Kong OX and Loginet, and also upgraded some circuit to 100 gig, which is indicated in the green circle with 100 gig test. So now Hong Kong OX is almost a fully resilient 100 gig open exchange. And this is the traffic we have for the Hong Kong Research and Education Network. And we also set up the persona in HKO for Harland. And as mentioned by Steve yesterday, APAN60 would like to have members to contribute at least one persona match, and we can establish the persona match with APAN60. And so you can see the forwarding path and the reverse path, the traffic pattern between JUCC and all the partners in APAN60. And Harland has also been protected by DDoS medication vendor. And as you can see, the normal traffic is the green line. In case there is a malicious attack, our lateral will indicate it to the DDoS medication platform that they will announce our AS number through the DDoS platform, and the malicious route will be flowed to the DDoS platform, the scrapping center, and then clean the traffic and going and have a GRE tunnel forwarding back to the Harland. About the upgrading upcoming plan, sorry, yeah, two sides. About the upcoming plan, we will upgrade our HKOS router in this some autumn, I think, or winter time. And we have planned to join Manus. We will also have more bilateral peering with APAN60 member, and we will also upgrade our persona to 100 gig. And this is the cross Pacific Ocean peering. We have only one peering, so we want to establish more peering. And this is a Manus. Our readiness is we have done almost everything except the RPKI. Yeah. And this is our website. You are welcome to go to our website. And this is the last slide about this APAN60. This is the network sponsored by Hong Kong Telecom. They have a 10 gig link for us to go to internet. And thank you for Juniper and Frocus. They sponsor the router, firewall, and the access point for us to connect to the internet. I think you have already loaded the SSID and the password. I think that's all for my presentation. Thank you very much.
So since we are run out of time, so yeah, no question.
Yeah, so thank you, Senator.
Yes, thank you.
Thank you.
So can you stop the share? Oh, sorry. Okay. Oh, yeah. Okay.
Zoom can also.
So since the function is online, so I can go to the from the event, so okay, so it's my video.
Hi, good morning, everybody. My name is Thomas Arnetta from Internet 2. My role with Internet 2 is I'm the International Engineering Program Manager. So as many of you know, Internet 2 is unlike many of the NRENs here in Asia. We are a member-funded nonprofit. So therefore, we have memberships from higher ed, federal government, and research institutions who essentially co-fund the network and we manage it on their behalf. These are just Internet 2 by the numbers. I'd like to pay special attention though to our network capacity this time. We are operating 800 gig plus wavelengths and 32 terabits per second capacity across our backbone. This is slowly going to be approaching 1600 gig and 50 to 74 terabits per second as new developments are coming online. As we know, changes in the United States in terms of AI and the technology stack there is developing such a rate. We'll soon be able to share how we're augmenting our network at the optical layer to see what's new. This is a pretty general idea of our backbone. We have infrastructure all across the United States. You see here these blue clouds. These are our cloud on-ramps where we co-locate and offer direct connections to the membership to cloud service providers such as AWS, Google Cloud, Azure, and we offer that as a service to augment their cloud workflows and storage and so forth. And you see the dashed lines here, particularly between Seattle and Chicago. And then as well in California from Sunnyvale to Los Angeles, that is leased capacity that we essentially buy from other regionals such as Pacific Northwest, Gigapop, Scenic, and Boreas. And this is kind of a general look at to see where we fit between all the regionals. All these other lines here outside the dash is the regional networks throughout the United States, which we support as sort of a transit provider for research and education. And in terms of our role in Asia Pacific, we have a co-funded link between Guam, Singapore, 100 gig, and that is probably see there Guam SG. That is with ArenaPac, ARNet, ourselves, and Transpac. So that's a co-funded link that we have our role in the consortium. In terms of our technology stack of how we are at the hardware level, for our core and aggregation, we are using the Cisco A200 platform. At layer 1, our line system is operated by Ciena. We have IRU on our fibers, and those fibers are Corning's SMF28 Ultra. And as well, we have these OSDF, if you're not familiar with it. That's essentially a cache network we have for researchers to store their data to be able to pull it throughout the country. And we use Perp Sonar to measure things. And Arista as our global exchange point providers. On the topic of global exchange points, we have 3 locations that we are present in. Boston, New York, and DC. So for Internet 2, we have a 400 gig between Boston and Paris to Japan. And then we obviously support the mainland New York infrastructure there for other providers such as NII and SURF to come to the United States and DC as well. This is our packet network topology. So essentially these are just routers on our network, and you can see how we designed our network to have multiple links between sites to offer the most diversity and to be able to transit the maximum amount of data possible. Those blue icons, those are our aggregation. So that's additional to support cloud and commodity peering directly to cloud service providers and such. The services that we offer these days are layer 1, obviously you can buy just a direct wave from us, 10, 100, 400 gig. Layer 2, we offer a service called AL2S. Essentially, you can build your own layer 2 connections as self-provisioned through our portal. And layer 3 IP, so BGP, and then you would transit RNE international links. If you see here, there's also rapid private interconnect and cloud connect. Those are essentially, they mean the same thing. There's cloud on-ramps for the membership, and those come in different sizes in terms of bandwidth and capacity. And there's also, we offer a global DDoS similar to HARNet, same design. We trigger prefix that we see as being attacked. It gets redirected to a scrubbing service, and it is cleaned, and then it's resent out. So these are the type of collaborations we do, and we offer these types of services to the membership for them to be able to take advantage of it. In terms of RNE-IP, the model is pretty simple. As a transit provider between the regionals, Learn here, this is not to be confused with Learn in Sri Lanka, this is Learn in Texas. They have their own membership, these campuses, and when they need to get to another regional, say for example, Scenic in California, they would use Internet 2's capacity to get there. And to get to you guys to access data, to collaborate and exchange traffic, we would provide them the transit, whether that be through APAN or through ANA. That is our role in where we fit between there, and same with ESNet, who's a specialty science DOE. ITPX, so we've established our own co-location and infrastructure to support just commodity. So outside of just having a regular commodity service and to not mix it with R&E routes, we go through and we peer directly with these providers and these large co-location facilities, such as like One Wilshire and Los Angeles. And we offer that to the membership at the speed that they get, and say 100 gig, 400 gig when they directly connect to us, versus buying a commodity link from NTT or AT&T and having to pay at a 95 percentile rate per megabit. From us, they just get it, and it's also at a better performance and also closer in the network. This is our capacity today. So if you pay attention to the top row, those are all the locations: Ashburn, New York, Chicago, Dallas. And then you're going down the left, that's the peers, and you can kind of see the total capacity they have between these providers. And then also the public exchange point. So right now we're approaching close to 1 terabit in terms of how much capacity we're bringing in, because as we're all aware, research data is just not living inside of R&E anymore. It's living on CDN, it's living on Google Cloud. So we have to make this available in another method outside of just general R&E infrastructure. Inside console, this has been a big focus for us since we rolled out NGI, which is the network the iteration we're on right now. This is a online web console that anybody can go to, and it can be, for one feature that it started with was Looking Glass. So you can verify link status. You can look at interface statistics. You can also understand what routes I'm sending to you and what routes you're sending to me. So it's a form of troubleshooting, and you have pretty much full insight into the network with the limited options you have. There's also more things we've done to it. Primarily, it's with community. So there's identity access management. There's also virtual networks for layer 2, as I mentioned earlier, L2S, and then our new. And so here, this is just what it looks like when you are building your own connectivity into when you build an L2S. And this is all supported by using a network service orchestrator from Cisco, and then also Nautobot to store all this data and make it available. The newest feature we rolled out is in terms of routing integrity and resilience. This is route reports. So what you can see here is if you are managed compliant or not, and you can see if your routes are being accepted and rejected and what are the reasons. So we're putting essentially through Inside Console the network in the hands of the user so they can do as they wish with it and to understand what it's like. We're going to take that even further, and you probably know the industry term of cloud router that such as Megaport uses, where you are building your own layer 3 network on top of there, and we're doing that now. So we're going to be adding route policies to accept and drop prefixes, and then route inspector as well to see more interface statistics and data available to you. Moving forward, though, because we're a research network, collaboration is so important to us, and because our membership consists of higher ed, the federal government, and industry, we work together to solve problems. And what that means is using the technology like Inside Console through API and get that into the hands of the member to make their own network that they see fit. Kind of going into these type of questions they like to ask us in terms of what we can do better for them, and then we start to build that. One of those recently is with a network in the Northeast where they essentially purchased the infrastructure from us, our routers, our capacity, and they met us in the co-location, and we give them through Inside Console the power to control how the router operates. And this way, they don't have to purchase co-location, they don't have to purchase routers, and to go through licensing and contracts. That's all with us, and they are seeing this as a way to move faster, to exploit the talent that we have and the skills and expertise of our software development stack, and to operate the network. One more very interesting is how we are leveraging our optical platform. So N-Wave is NOAA, the federal government network, and WRN, our Western Regional Network. These are built on top of Internet 2's backbone. So we have this capacity to just essentially let them build their own network that they see fit. These are some more of the collaborations we've done in the past, and that we're going to continue to do in the future. Thank you very much for your time.
Thank you very much. right on time.
Yes. No pressure.
I am. So the next question will be, officially, that. So if you do have a question for the two, so that we just Thomas, you answer the facing.
Oh.
Yeah.
Okay.
Okay, slideshow. Okay.
Alright, good. So that you have the around 10 minutes to deal with that.
Hello. Good morning. My name is Patchy Lee. I'm working for TNCC in South Korea, and we manage Asia Connect project, and we also operate 10 network. It's really glad to meet you all. Wow, huge people up here. Okay. Okay, I would like to provide a brief update on the TAIN network, including activities we have carried out and those planned maybe for the period from September this year to February 2026, a time frame during which we anticipate European Commission will step back, one step away from direct engagement in the project. So firstly, here is the paying network and activities. Here is the updated topology map as of the last day of April this year. There has been some, it doesn't look clear, but yeah, some changes. Yeah, which is reflected in the next slide. Firstly, I mean, Bhutan's 5 Gbps, as you can see at the upside, I mean, provide NKN has been offline since this year May. There is currently no clear timeline for when the link will be restored. We are talking with NKN for the matter, but it's not unclear. For next one is Cambodia's 10 meg BPS link has also gone offline. We think regard is likely due to the geopolitical situation between sensitive about to say between the neighboring countries. I mean, with the neighboring countries. Okay, hold on. So for this Cambodia link, we are working to restore the connection with the support from the service provider, which is from Thailand, and also with Common. But this link also, the time for recovery is not quite uncertain, remains uncertain. Okay, next, let me provide you overview of the activities very briefly carried out over the past 6 months. During this period, we supported 3 technical training sessions and 1 week leadership development course. We also awarded 2 contracts for generative AI training programs. Okay, let's get into a little details of them. First one, well, we supported a capacity building program in collaboration with APAN60. which this year focused on a regional collaboration rather than the local approach taken last year. The program was conducted across 3 venues, as you can see in the table. And we got about trainees of total of 104 individuals, primarily in network automation, security, and monitoring. The program placed a strong emphasis on hands-on lab work to reinforce practical skills. Having this opportunity, I would like to actually extend my sincere thanks to BDRAN, the president, Thailand, hosting these 3 wonderful events at their respective facilities. Here are some beautiful pictures that you can see. And this year, as I mentioned, we offered Asia Connect leadership course, even though it's 1 week in Bangkok, Thailand, held from late April to early May. The program featured a distinguished lecturer from ANET, Australia, and welcomed 22 participants from 13 countries. We plan to expand and further develop this program in the next phase of Asia Connect, as it offers a quite unique opportunity, a complementary approach, actually, I can say that, to our traditionally technical engineering focused capacity building efforts. This year, this half early year, we also have awarded 2 training programs in the field of generative AI. Shown in the table, as shown. These programs are designed to empower engineers in their day-to-day operations, including applications with the networking domain. The principal investigators, PIs, are expected to carry out their respective programs by the end of next month, which is the expiry date or time of our current project, Asia Connect. Now let's look at the planned activities for this month and next month. Actually, the reason, as I just mentioned, I'm presenting you this 2-month information is that Asia Connect project will officially conclude on 31st August. We are working quite diligently to ensure the continuation of the project with ongoing support from the European Commission. We believe if it all goes well, we expect the next phase to begin in early next year, hopefully March. We have issued termination notices to both colocation service providers in Hong Kong and Singapore, as you can see in the table, to reduce 1 rack per site. We regard this measure is expected to save up to 62,000 euros annually. The 2 training programs, as I mentioned earlier, is going to be carried out by the end of next month. We'll also hold 2 signing ceremonies, one with APAN and the other with APAN this afternoon during the latter part of opening ceremony. I also would like to take this opportunity to thank Francis and Roshan. How is it? My time?
We have around 1 minute today.
1 minute. Okay. For the kind of assistance, and finalizing these agreements. Lastly, the link to e-compendium has been posted on the website. Next one, planned activities for the transitional period, as I mentioned, 6 months. Yeah, we expect to have this transitional period in place while awaiting the European Commission's re-engagement. Assuming everything proceeds smoothly, we anticipate, as I mentioned, early next year. So during the transition period, the primary objective is to minimize the expenses to optimize our spending. So first, regarding the TAIN network-related activities, the reduction of one rack per site will be carried out, decommissioned. So also a tender process for the TAIN NOC will be carried out, launched during this time. In addition, discussions and decisions regarding the future of operational methodology for managing the TAIN parks will take place. And secondly, you can see capacity building program in collaboration with NSRC. We are trying to accomplish that since NSRC is quite famous for their engagement with in the fields of campus related with campus training. So, and the last one is about we are trying hard to restore the connectivity we lost in 2023, which are Indonesia and Vietnam. So we found out one opportunity, which is quite a huge opportunity, a humongous opportunity, which we could utilize, which is ASEAN HPC project. So we will do our best to accomplish our purpose. Okay, that's all I have. Thank you very much.
Yeah. We have my agenda ahead, right? So what's the agenda ahead? So,
Yeah.
so think about it.
Okay. No question?
Yeah, well, we can take maybe 1 or 2 questions, but before going to the other side, we come into the city. Then
Oh, no.
Thank you. Thank you.
if there's no questions, so that's it. Okay, so then we're gonna put the diet update from the Assam from NII.
Thank you. Thank you.
Thank you.
Yeah. Sorry.
So that the we has some or someone who have the question about us. Wow.
He's not sorry.
Okay. So that so the do you have any question? Yeah.
Help is not his.
Okay.
Can you go to your Zoom?
Yeah.
The Zoom first.
Oh, yeah.
Is it on internet?
Yeah.
Your Zoom? Is it the right number? Go to your Zoom.
Yeah. Zoom. Yeah.
Have you entered this one?
Sign.
This one.
Yeah, sorry. 무슨 시험이다. 아니, 좋았어.
Oh, you,
あ、じゃあ共有すみません。
You leave already.
you leave.
ごめんなさい。はい。
No. It's
Yeah, yeah, sign.
sign in the Zoom first.
Yeah. Ah, sorry. Thank you for support.
Sign in the Zoom.
Yeah.
Excuse me.
Yeah, yeah.
こっちで使いましょう。
あ、
こっちで
はい。
資料がない。
しようか。sorry for.
はい。
順番変えます。ごめんなさい。あ、
So that the
Sorry.
yeah, sorry.
Oh, yeah, so then it's, yeah, go ahead. So the he's from Nokia, head of the enterprise and business development from the so the and you're from the optical field, right?
That's right.
Yep.
But I'm gonna share my
Yep.
screen here.
Yes.
Okay. This one?
Yep. Slideshow.
You could be.
Yeah, excuse me.
Hi.
Hi.
Yeah, yeah, you can hold it. Yeah, just hold it.
Oh, you
up.
wanna hold it?
Either
Yeah.
way, that's fine. Yeah.
Okay. In the sun.
Good morning, everyone. Ni hao. My name is Sachin Jain, and I am responsible for optical business within Nokia for the APAC region. This is my second time in APAC. I was there last year in Osaka, and I'm really happy and glad to be here. I would like to start by thanking the Francis, Sato-san, APAN committee and all, for arranging this wonderful event and bringing us all together to discuss what's going on in the research and education network industry and the challenges that we see. And I'm going to talk next 10 minutes on the terabit in motion. That's a topic I thought of giving name to my session. We'll be talking about some challenges in the research and education network that we see across APAC globally and how do we want to address. I'll keep it very short and simple because of the time limitation. I understand everyone has to present in 10 minutes. We have another session at 3:40 or 3:35 where we can go deep dive with the tutorial on Nokia's optical portfolio and what's happening in the data center industry. Okay.
You have 10 minutes, okay?
10 minutes. I'll give it 10 minutes. Okay, so I'll start with some challenges that we see from the network perspective. I divide them into four main buckets. First, of course, the network that we operate, all of us run, they are used for different purposes, whether it is wide area network, data center, cloud. So how to manage that network. Second is how to scale that network, because we all know fiber is scarce and fiber is an asset. So how do we scale that network? Third is on the automation side. How do we automate the network to make it more simplified, to monetize the network? And what are the different challenges that we see and how can we help them with the help of automation? And last but not the least is the security. This is a very, very sincere and severe topic that we should talk about. When we talk about these challenges, we talk about three dimensions. As I said, first is scalability. What does scalability mean? How do we scale our network? Whether it is maximizing the spectral efficiency through coherent detection and signal processing by the latest chipsets. We double the capacity of the fiber by using C-band and L-band together. And third is, of course, we can use packet OTN for the ODUK granularity by doing more traffic. So we can talk about that. When we talk about automation, we talk about AI. Of course, everyone is talking about AI these days. This is the buzzword in the industry. Machine learning algorithms and open APIs that helps us to connect to different interfaces, do a lot of open API stuff and integration. We talk about consumable use cases. We talk about integrated real-time analytics. The integrated real-time analytics could be using through fiber sensing, and we talk about closed-loop automation. I'll little bit touch upon it in my subsequent slides. And we talk about increased network scalability, minimizing the complexity while keeping the total cost of ownership as minimal as possible. Last, as I said, we talk about layer 1 security. We will talk about AES-256 encryption. We talk about quantum safe network. Quantum safe is something that is going to be a very important and key requirement from the network, especially for the research and education network, because we are operating very sensitive information on those kind of networks. For scalability, the way Nokia is offering is we are talking about new coherent optics, which is a Nokia PSC6S chipset based on latest 5 nanometer silicon PSP. It is in single card, you get at least 2.4 data capacity on a single line card. It is in terms of performance, it is much superior, 3 times the performance of 800G, and then you have reduce the network optics by 50% because we are having a dual port card with the same dual port of the same line card with 1.2 data capacity each. And in terms of sustainability, it has 40% less power per bit than the previous generation, which was the PSC5S 7 nanometer, and it is up to 60% less network power requirement. When we talk about from the first generation of 100G, it is 90% less power. So that's how the chipsets are evolving, and this is available across all the platforms that I'm going to do. So when we talk about this 5 nanometer DSP, depending on the fitment and the requirement, you can have the extreme that you see PSIM, which is a DCI platform, 600 millimeter deep, a pizza box kind of a thing. You can implement here the DMX card. You have a PSS16, which is a 300 millimeter telco form factor, and this one was IT form factor, so this is telco form factor. You have a OTN switching where you have the same PSS6 gets implemented, and we also implemented into the SLT PSI, which is for primary subsea applications. The way it has evolved is earlier, if you had to carry 800 GBs, so you require in the current generations, you see for each 800 GB, you need to have equivalent 800 gig wave mapped onto the line card. But with PSA6, the way we have implemented thanks to our chip-to-chip technology, even if you have 3 800 GBs, we can map them into 2 line ports of 1.2 tera. So 8 is 2.4 tera capacity on the 2.4 tera capacity on the client side, but mapped onto only 2 line ports. So this minimizes the number of optics you need on the line side, and it results into up to 20 versions saved. PSA6 is now more mature and feature-rich. What do I mean by that? We talked about C-band, we talked about L-band. So this simply means, in short, you can double your fiber capacity by using C plus L-band, and we have all the transponders available for C-band as well as L-band here. So L represents the transponder for the L-band capacity. As I said initially, how to double the capacity, because fiber is an asset, and especially in the research and education network, we do not have ample fiber. We cannot just keep on burning the fiber for increasing the capacity. The way we operate is the same single pair of fiber. You can have C-band system and you can have L-band modem as well. Okay, so it's a pay as you grow. If your capacity of the C-band gets exhausted, or if you want to monetize your network by giving the capacity to OTT players or hyperscalers, you can offer them complete L-band or a spectrum sharing. So instead of 4.8 tera, which your C-band is 48 gigahertz, you can double the capacity to 9.6 terahertz. We are also working with the integrated C plus L-band, whereas it will be a double stop C plus L-band and L cast. This will increase the capacity to, as I said, 10 terahertz, and it will simplify installation and operation. You can have different architectures, whether it is CF, which is colorless flex grid, or a CDCF, which is a colorless directionless flex grid architectures. So on the day one, so you have both the options. You can start pay as you grow. You can start with C band as the capacity exhausts. You can add on to the L band, or you can, if there is a business case justify, if you have a potential tenant or a customer who's asking for new capacity, you have the requirement from the day one, you can start with the C plus L band directly. So on the same pair of fiber, you double the capacity. Third thing, as I said in the initial, I talked about scalability, I talked about automation, and I talked about security. So this is automation. Wave Suite is the Nokia's nervous system or practical system. Nervous system means you have, this is all modular or software as a service. You can have a network operations center, which is your NMS. You can have advanced diagnostic. You can have OTDR functionality. You have health and analytics. Wave Suite Planner is our engineering and planning tool. You can simulate your network in a real-time basis and do some capacity dimensioning and restoration analysis. You can have synchronizer, you can sync as a service or for sales distribution. Resource controller is for multi-vendor operability, and service enablement is how we monetize the network. So all these are modules, software modules. You don't have to have all of them on the day one. As I said, we always believe in a pay-as-you-grow in the requirement-based approach. You can start with any one of them, and you can keep on adding the modules as you think the requirement keep coming in. I'm going very fast, but I'm happy to go deep dive into each one of them in the session later on, but I'm just giving you a glimpse of what all we have. So as I said, to summarize the Wave Suite nervous system, it helps to end-to-end lifecycle management. It helps you to optimize the network and operations, provisioning, visualization of the network, scaling the network, supporting growth, security, and efficient service delivery, vertical provisioning, and you can monetize your network asset by enabling slicing, visualization, assurance, network monetization. Last thing I want to touch upon is security. So I'll quickly go on to the different blueprints that Nokia is offering today. So you see here 4 blueprints. To the extreme left, you see the blueprint, which we call as a pre-shared blueprint. Here, these are the connectivity enablers. These are the IP and optical equipments. Here, the keys are shared manually. So there is a risk of scalability, but this is quantum safe. Somebody wants to go ahead with this one. Second is the classic blueprint, where in addition to the connectivity enablers, we add on to the Nokia SMS, which is a security management server responsible for key rotation, key generation, and key distribution. Again, quantum safe. So these two are Nokia blueprint with Nokia products. We are also having QKD hybrid blueprint as well as blueprint with the SATCOM and the satellite QKD links. As I said, security management server is a centralized server. It's a crypto officer, and it is used for key management, including key generation, key rotation, backup, and health. It is CCEL4 and C, and all certifications are here on this one. So as I said, blueprint 1 and 2 are 100% Nokia products. Okay, so we all do end-to-end services as well. Whereas blueprint 3 and 4, not all hardware and software are from Nokia. Okay, we do some validation. We work with the QKD vendors and we implement that. So just to summarize, Nokia, I think you might have heard recently we acquired Infinera. So now the new Nokia, the bigger Nokia is ready to speed up the innovation, and we have the end-to-end portfolio. We have global scale with a local presence everywhere in the APAC region. And of course, we proudly say that we have the number 1 market share, excluding China, number 2 in APAC, number 2 in India and India. So please feel free to reach out to the Nokia representative. We have Philip Girard in the audience here, and myself, don't hesitate. Just to summarize, scale up to terabit and scale up with Nokia. Thank you.
Thank you. So the so the high preparing by sort of the thank you. Okay, so the who is doing the optic things in your environment? Raise your hand. Only one. Who is getting interested in that? Oh, 3. Okay. So do you remember Casey? So that you are there the potential customer for you. Okay.
I- There.
So the next speaker will be
Jane Chung.
You try soon.
yeah. Yes, green button. Yeah, so so similar updates, the current network. And she's the assistant manager from the current, but okay, it's make it bigger. Yeah, yes. And okay.
Good morning, everyone. This is Hyung Lee, the Assistant Manager of Korean NOC. I'm very glad to share my the current Korean status and updates. Here is the context. I will start my presentation with Korean introduction and then our Korean updates and main project. Finally, share our best use cases. This is the network topology of Korean. As you can see, there are 10 POPs across the country. The domestic backbone is mainly built with 100 gigabit per second links and support up to 22.8 terabit per second. And the Seoul Daejeon and Seoul Pangyo links are configured with 400 gigabit per second and additional 400 gigabit per second connection to Daegu, Gwangju, and Busan are planned. And this is the international POPs. The international POP links are in Hong Kong and Singapore POPs, so we have 2 international POPs. And Korean has total 90 users. This data is as of July 25. Korean has 90 members institution, including 22 industry section, 23 the universities, and 31 research institutes, and 14 hospitals. The previously mentioned users are primarily concentrated in Seoul metropolitan area. The main users are located in Seoul, Pangyo, and Daejeon. And then I will explain about the current affairs. And this is the domestic backbone of Korean. Sorry.
Take your time.
Korean operates a nationwide scale SDN and updated net flow-based controller annually. The SDN switches operated 400G capacity and are deployed across 6 cities: Seoul, Daejeon, Pangyo, Daegu, Busan, and Gwangju. And we are planned in this year in 2025 on new POPs in Japan. So there are possibility to connect Korean NOC to Hong Kong and Singapore and Japan POP if the organizational links. So we kindly ask your cooperation. And now I will explain about the main project of Korean. This is the 5G A testbed. Current is operating on nationwide 5G open testbed at 4 key locations in Korea to contribute to standardization of emerging 6G technologies. The testbed supports MEC-based 5G convergence services, the national 5G infrastructure, and testing of associated terminals, devices, and equipment. Second one is quantum cryptography in Korean. For the quantum cryptography pilot project, the Korean NOC operates on nationwide test bed divided into 3 regional rings, as you can see in this map. Center, the QKD, and Hona, the test bed, and Yeongnam, PQC. These rings are interconnected through current paths, with 2 of them built on dark fiber infrastructure. The Daejeon Busan section is configured through Korean's ROADM optical transport network. Our equipment is centrally managed through a QSDM-based 3EMS platform. The third one is the AI Network Lab. The AI Network Lab provides research and testing environments such as a test room, shielded room, and training facility to support the study and evaluation of next generation network application of technologies. And this is the Net Challenge Camp. The Net Challenge Camp is a K-digital competition for university students that utilize the current test bed aiming to foster talented individuals. The program is currently in its 12th year. During the camp, Korean NOC provides students with the resources they need for their projects, such as OpenStack VMs, HPC, and KPass. And now I'm explaining about our use cases. This is the case 1 from April 2021 to December 2025. A3 has been conducting research and validation through Korean on a project aimed at realizing ultra high performance and ultra precision 6G core technologies, ushering in an era of large scale immersive communications. In this project, A3 achieved ultra low latency of under 5 milliseconds over an 800-kilometer distance using the current infrastructure and demonstrated world-class terabit per second level wireless transmission technologies. Additionally, A3 showcased its cutting-edge communication capabilities to the general public by delivering real-time 4K high-definition rock, paper, scissors gameplay and seamless remote metaverse concert performance. We have 2 videos. Here. Oh, wait a minute. This is a rock, paper, scissors game. And no, there are no latency. One studio is Busan and one studio is Daejeon. The distance of 800 kilometers, but there are no have latency. So you can see in this video. And the second video is the metaverse concept. They move in the studio and the screen is in Seoul, they can show. case. And the second case is the collaboration with Thailand. A Convergence Innovation Education Center at Konkuk University in Korea is conducting research project, including telecommunication related ODA, in collaboration with developing countries in Asia by utilizing the Korean and Pain networks. In 2025, as part of a student-led project, the center is using an IoT SDN controller within its lab to monitor and analyze growth in a smart farm environment in Thailand. As shown this diagram, this international smart farm testbed is being developed through the interconnected quarantine and Thailand network. And I will finish my presentation. Thank you for attention.
Thank you very much. Are there any questions? Otherwise, so that you go to the classroom. What may I? Thank you very much. And with a great video. Okay, so can you stop sharing the screen so that oh.
Thank you.
John, do you have?
Yeah, okay.
Yes.
Thank you.
Okay.
Just bring that.
Why?
So okay, the sign that up there.
Yeah. Hi everyone, sorry for my confusion. I'm Osama Akashi of NII. Today's my presentation is about the new 400 gig international line report and about the new DXP in Tokyo. So this is a brief introduction of the SINET. As you know, SINET is a Japanese academic network. SINET provides international connectivity and connects the Japanese organization more than about 1,000, including the university and research organizations. So this is SINET international lines. So left line shows the SINET lines. We provide the 4 international lines. One is Tokyo to EU area, Netherlands, for 100 gig line. And another one is Tokyo to Los Angeles, New York, and similarly, Netherlands. This is 400 gig lines. This presentation is about this line's operation there. And as far as the Asia Pacific area, we also provide the Japan to Singapore and Japan to Guam lines for provide the connectivities. So we are acting with collaborating with the AER, ANA, and APAN60. So thank you for the daily collaboration and support. So this is another map. So this today's my presentation is about this red line. So Tokyo, Los Angeles, New York, Amsterdam lines operations report. And another one is new GXP introduction. So this is a brief report of the operation. So previous APAN, we reported that we have just started the operation from the 400 gig Japan to Los Angeles. But we are actually suffering the instability, namely flapping. So we sorry, so we have to identify the root cause. So collaboration with the Sato-san and the KDDI team. So we making a physical loop and try to test and try to find out the suspicious area. So after that, so by replacing the 2 interface card, 2 transmitting card, device card, so in the landing point in the United States, So one is for direction to United States, one is direction to the undersea cable. So by replacing this card, currently we think that it became stable. This is a brief report of the operation. Another report is the introduction of the new GXP in Tokyo. So we define the name is Fuji XP. Formally, this is sorry, this is the name of the Federated Units of Japan IXP. URL is here. Just started operation from the July 1st. But intuitively, it's just no, this. Okay, okay. It's just Mount Fuji. Name is came from the Mount Fuji, and Fuji XP is the formal name. So website is here, but actually content is currently being enhanced, and contact information not available, but will be available soon. So and this constructed under the Signet website, but this URL will be moved to the Fuji XP or Shinji domain in near future. So Fuji XP provides Fuji XP is located in the 2 data center in Tokyo and provide 2 physical routers, provided by 2 physical routers, and provide a layer 2 Ethernet connection with a speed of 10, 100, or 400 gig bps. And the important point is it is also connected the conventional current GXP Tokyo. So it is again this PGXP is procured and operated by Signet, but supported by SIG. SIG is the alliance of the Japanese NREN. Member is Muffin, NICTJGN, NI Signet, and Wide Arena Parts. So we have just started the operation. Currently, 3 new connection applications are in progress. So this is the structure of the Fuji XP. As I mentioned, the router 2 routers are located in the 2 data centers, and here current GXP Tokyo are connected by this red lines. So currently, this RC ASNet Muffin, JGN Signet, Transpac wide are connected GXP Tokyo, but now we can also connect it to the new Fuji XP. Shinji members also will be connected to the new Fuji XP. Of course, Signet is currently connected to the Fuji XP. So this is topology map enhanced by citing the Shinji members lines. So Signet is a blue line, and Arena Park with yellow line, and Harnet, JGN, Singapore, Japan to Hong Kong, Hong Kong to Singapore is a green line, and sorry, orange line. And Mahmoud line is Japan to Manila, it's green lines. So this shows the current topology focusing on the Shinji members. Okay, this is all. Yeah, sorry, I spend more time for preparations.
Okay, so
Yeah.
thank you very much. So,
Yeah.
So we have 3 minutes left, but if you have any kind of the questions to sign it or not, so if you want to know the outage of the Japan US circuit, reach out to me. But no? Oh, there you go.
Right, the 400 gig link is open for use. Is currently available for use, is it? The 400 gig to Europe is operational.
Yes.
I heard that Korea is also thinking of a 400 gig thing as well. Because yes,
Hi, now we have planned to upgrade our personal backbone. Yeah, it will be next June.
Next year, yeah.
And we are considering the 400 between from South Korea to North America.
Yeah.
I think it's so we could be the option.
Yeah. Yeah. Currently, I think this current 400 gig lines are stably operations. So I hope this function is successfully successfully evolution.
I think in general, I was very pleased to hear that Korean is planning connectivity to Japan. Because I remember one time there was quite a number of cuts, and Korea had to go all the way to the US and come back to Asia. And by connecting between Korea and Japan, there's more resilience. You know, you got either coming down to Hong Kong and downwards to Asia region, or Korea, Singapore directly, and now Korea to Japan, and from Japan, that number of parts coming down as well. I think that's really good for the resilience in our region, East Asia region.
Yeah. We welcome to the connection to the Fuji XP and waiting for the request. Yeah, thank you.
Don't think I'm going to the my colleagues. Thank you very much.
Thank you.
Thank you.
Okay, so you have around 10 minutes.
Okay.
So you can
That's
give
okay.
the
What?
time for everybody. We can have some coffee.
Already share.
Yes.
No.
Jonathan, let me have this one. This one. Yeah. Okay.
Okay, hello everyone. I'm Konan Mutashi from APAN60, and today I will share 3 quick updates. First is persona, and second is network issue and resiliency in Asia, and third is the GXP Tokyo update. So let's start with the persona update. APAN60 has been actively involved in the deployment and development of persona since the beginning of the project. APAN60 operates 2 hosts, and one is a 100 gig testing point as below personal lookup service, and the other one is central management virtual machine. We have been maintaining and compiling performance measurements between GXPs and APAN nodes, you can see the results of our dashboards at this URL. Regarding the update of personal dashboards, we have restarted testing with SANET Internet 2 for GXPs. And for APAN nodes, we have resumed testing with CUHK and Coronet and Mylen. Thank you all for your kind cooperation. And then after visualizing network performance, we found that some nodes are not well connected. We believe that persona is not just for troubleshooting, it also helps improve network performance through visualization. In R&D networks, fast and reliable network is essential for data exchange, collaboration, and innovation. So we need active monitoring of network performance in addition to connectivity monitoring through network performance visualizing. And then the next update is about what happened during 6 months in the Asian R&D network. To start off, we asked APANET members to share information about outages and maintenances in 2025. Thank you so much for sharing information and kind cooperation in preparing this presentation. Over the past 6 months, there were a total of 67 outages, including 8 fiber cuts and 12 faults and 47 maintenances. This slide shows a list of outages and disruptions that lasted more than 1 day. Compared to previous year, there were relatively few long-term incidents or maintenances. However, planned maintenance on the Japan, Hong Kong and Singapore circuit from June 25th to July 2nd caused the isolation of the APAN-JP Hong Kong side. The APAN-JP backbone is, designed with multiple backup paths and automatically rerouted thanks to the strong collaboration with many of our partners. This redundancy has improved our network resiliency of our network. So during the planned maintenance window on the Japan, Hong Kong, Singapore circuit, we expected to reroute traffic through these backup paths. However, current international network had been undergoing reconfiguration since mid-January, and we lacked a clear understanding of the availability via current backup paths. As a result, during the 7-day maintenance period, the APAN-JP Hong Kong side is experiencing a total of 16 hours of isolation. And the availability of the APAN-JP backbone decreased from 100% to 99.8% over the year. This isolation event takes us more to take faster action. Yes, with the kind support of KIST, HKIX, and Shingaren, we successfully established an additional backup path via KIST Korean Hong Kong and Hong Kong Singapore. This new backup path enhanced the resiliency of the R&D network in Asia region. I'd like to thank KIST, HKX, and Shingaren for their continuing kind support. We believe that reducing isolation events requires not only having mutual backup paths or multiple backup paths, but also improving communication and visibility with our partners. Then finally, I'd like to share the update of GXP Tokyo. This slide shows an overview of GXP Tokyo's connection status as of APAN59. And then here is the current overview of GXP Tokyo's connection. We migrated several 100 gig connections from MX routers to QFX switches. And as mentioned in the NI presentation, new GXP Fuji XP launched, and on July 7th, GXP Tokyo was connected to Fuji XP with 4x100 gig links at KDDI Otemachi. And with the launch of Fuji XP, the network between Asia and Japan was rebuilt for continuous delivery and simplicity. To align with Fuji XP's environment, we made several changes to the APAN-JP backbone. For example, IGP was used as ISIS, so we changed from ISIS to OSPF. And we unified ID schemes as IP addresses and route distinguishers with Fuji XP. On this new network, services are separated by using VRFs. So APAN-JP is now operated as just one of the VRFs on this network. For this change work, we built a virtual testing environment using Container Lab. In this testing environment, we deployed 8 Juniper VGNOS router like MX router for APAN-JP router and EBGP router, and 2 VGNOS Evolved routers for Fuji XP demonstrated. Container Lab enabled rapid setup of the entire test environment and easily simulate the backbone. We validated backbone configuration and connectivity for L2 VPN and L3 VPN before and after migration. This is a sample image of how we created a testing environment. After preparing a YAML file and configuration files, we launched the virtual labo by simply running just run the deploy command. And in addition, Container Labo can automatically create an architecture diagram of the test environment with just one command. It was surprisingly easy to use and greatly assisted our validation. After validating the configuration, we deployed it to production environment. The configuration successfully worked in the production environment. However, performance issues occurred on one of the backbone core router, on our backbone core router when processing full root. Restarting the RPD process resolved it, but this reminded us that the virtual testing environment is very useful, but it is difficult to fully demonstrate the behavior in a production environment. Regarding our future work, we will continue to refine our backbone, such as migration of plans to L2 VPN and implement traffic engineering using SR-MPLS and TILFA to improve the Asian Japan network. This is our summary, and thank you for listening.
Thank you. Are there any questions? So there we got here. 2 minutes. Okay, then this is the end of the first session of the network engineering, and thank you for coming. And we will resume this session in 30 minutes, but 10:45, and please do come back and get some coffee. Thank you very much.
Thank you.
Thank you.